Okay, so a very good morning to all my coursemate. So this meeting is met especially for the discussion for our group assignment, which is assignment 3. And then the group member consists of Hafizah Marlisa, Hanisah Binti Ahmad, Zeng and me myself, Vincent Zeng. So this assignment is about the virtual work method to determine the vertical deflection by using the virtual work method. So this is question 1. So I will start the discussion now. So the question 1, firstly, we will take moment about A, and then with that we can get the vertical reaction at D. After that, we will use the summation Fy equal to 0, and then we will get VA, vertical reaction at A, which is 28.8 kilonewton in the upward direction. And then for unit log, since the question required to find the value for vertical deflection at B, so we will find the unit log at point B. And then by using again the moment equation, we will get VD equal to 0.4, and then summation Fy equal to 0, we will get VA equal to 0.6 for unit log. And then the deflection at point B, we will found by using this equation, which had been taught in the lecture video. And then we will consider 3 sections, which is from A to B, and then from D to C, and then C to B. So first of all, we will look for section A to B, which is the X bit in between 0 to 3 meter. The moment for the real beam is 28.8x, and then the moment for the virtual beam is 0.6x. These two we can get from this diagram and then this diagram. So by multiply the moment and we will get 17.28 x squared, and then we substitute into this equation, and then this EI is a constant which is given in this equation. So we can just leave it there at the end of the question, and then we will substitute in the EI value. And then now, secondly, we will consider section D to C, which is this part from D to C, and the X is between 0 to 1.5 meter from the right hand side. And then we will find that the moment for the real beam is 43.2x, and then the moment for the virtual beam is 0.4x. The multiplication of these two moments is 17.28 x squared. So by substituting into the equations, we will get the deflection for that part. And then lastly we consider from section C to B, which is in between 1.5 to 4.5 meter. And then this is the value for the deflection part from C to B. Lastly, we will add all that together to get the final deflection at B, which is 518.4 over EI, and then we substitute the EI value into the equations. So the deflection at B is 10.37 mm to the downward direction. So any problem, any point that you guys don't understand for question 1? If no, then we will proceed to question 2.
So for question 2, we have beam, and in A and C here we have something like pin. So we have to calculate the vertical deflection at B. So first of all, we solve for the beam. For real beam, here is the real beam. We find the vertical reaction for VA and VC. So this is how to solve for the real beam. We have here VC and VA. And then we solve for unit load since the question said vertical load deflection at B. So 1 unit load at B. So and then we get the value of UCD, and UAE. We have two sections, section A to B and then section C to B. Here's the equation to solve the deflection for the beam. We solve it one by one. First, section A to B, which is between 0 to 4 meter. This is the real beam. We cut into half here, and then use the moment equation. We find the m for real moment 42x minus 4x squared, and then virtual moment 0.5x. And then we substitute into the equation we get. So deflection at section A to B, 320 over EI. And then we move on to section C to B. Same method we use. First, we find the real moment and then we find the virtual moment. And then we substitute again into the equation. Yes, and 160 over EI for deflection for the section C to D. And then we substitute again the EI value where we given the EI value. Hence, we find the deflection for, this is for beam, and then since we have pin, for pin we use summation of P force L over AE times U force. And then we get 3.603 for the pin. And we add all together and then we get the deflection at B 7.256 millimeter.
Okay, thank you for your explanation. So I will proceed to question 3.
Okay, for question 3, we were asked to determine the vertical deflection at B given the value of EI. So I divide this question into two parts, which are from beam A, D, and also beam D to E. So for beam A to D, I determine the direction at A and also at D, and I found that both of them are 20 kilonewton upwards. So after that, since we want to determine the deflection at B, so we applied the unit load 1 kilonewton at B. So after that, we determine direction both at A and also at D. So after we find both of direction, we can start to find the displacement at B by using the integration of mm over EI. So for beam A to D, we can divide them into 3 different sections, which are from section A to B, section B to C, and also section C to B. So for section A to B, which are from 0 to 2 meter, find the visual moment and also real moment, and I get both of them are 14.2 x squared for section. Then we use the integration. I get them as 27.6569 over 8. After that, we need to determine from section D to C from right. So this is from 0 to 2 meter. Then we find the virtual moment and also real moment, and I get them as 5.8 x squared. Then we use the equation to determine. Then I get 11.34 EI. And the last section, which are from C to B, between 2 and 5 meter, determine the real moment and also the virtual moment, and I get 11.6x. Then use the equation, I get 81.2 over EI. So for section 2, from Binti to E, I determine the reaction at D and also moment at E. Then, as usual, you apply the load, 1 kilometer, then I get, and the new virtual reaction at E is 0.29 and also moment at E 1.16. Both of them positive upwards. So you find the virtual moment and also real moment, and I get them as 5.8x squared. Then we can use the equation. I get them as 61.87 over EI. So to find the deflection at D, we add all of the values, then I get 12.40 mm downwards. Thank you.
Okay, so thank you for your explanation. So let's proceed to question 4.
Okay, I will explain about question 4. Question 4 requires us to find the displacement at G. So first of all, based on the diagram, we found the vertical reaction for the point B and E for the real, and then we draw the free body diagram for the real diagram, and also we draw a real diagram for the virtual one by putting a virtual log at point G and calculating the supporting reaction at E and B. Yes, and then starting with find the deflation. So first on section A and B, then we can find that it is the 0 because the virtual moment is a 0. Then we'll proceed to the section of B and C. Calculating the moment of the real and the virtuals. Then using this equation, we find the integration. Then we get the moment at that section. Then we proceed to the next section, which is section C to D. Same thing by finding the moments for the real and the virtuals, and then finding the integration. we get the integration, then proceed to the section B and E. Now by finding the moment of the real and of the virtuals, and then same thing, multiply, integrating, we find the moment, the displacement, and then we proceed to the section G and F. And this part is also a 0 because at this part the real moment is a 0, so it directly is the 0 displacement. So we directly proceed to the section F and E, finding both virtual moments and then calculating the displacement by using the integration method. And then next we proceed to find the total displacement by adding all the value we find above, which we have total negative 7.8 millimeters displacement at the part G, which means it's downward. Okay. Is there any question about this question?
No question.
Okay, that's all from me.
So let's proceed to question 5. So this question is asks us to find the vertical deflection at C, given all this value, the more of inertia, the cross-section area, and the E value. So this question is again contain the pin section from B to D. So these values are actually very useful. So first of all, I calculate the EI of ABC, which is this beam, since the question asks us to find the vertical deflection at C. So the EI of ABC is 18.45 times 10 to the power of 3 kilonewton meter. And then again, I find the AE of this pin member, BD. So the deflection at C, the general equation is this, the integration from 0 to L. L is actually the length of this beam ABC, multiplication of moment over EI, plus with the summation of PL over AE times the unit load of the pin member BD. So this is the general equation that we use to find the vertical deflection at point C. So first of all, I will use the moment at A to find the reaction of FBD, which is the reaction from this member, FBD. So the FBD is 48.09 kilonewton. And then I use the summation of Fy equal to 0 to get the VA. And I get it is 11 kilonewton to the downward direction. So this is the apply load on the real beam. And then this is the unit load diagram for the virtual beam, ABC. So by using the equation summation, the integration from 0 to L, and then we consider two sections, which is from A to B, and then from section C to B from the right-hand side. So from section A to B, it is x in between 0 to 2. So the real moment is negative 11x minus 2.0 x squared. And then the virtual moment is negative x. So the multiplications of these two moments is 11x squared plus 2.0 x cubed. And then we substitute into the equations, we will get the moment, the deflection is from A to B is actually 37.33 over EI meter. This EI, later on, we will substitute the value that we calculate at first of the solutions. So secondly, we proceed to from section C to B. The distance is also 0 to 2. And then we will get the real moment and the virtual moment, and then multiply them together and then substitute into the equation again. We will get EI is 40 over EI. And then we add both of these 40 over EI, add with 37.33, we will get 77.33 over EI. And then we will substitute into the EI value, which is 18.45. And then we will get the deflection is actually 4.19 mm. But we haven't done yet because we haven't considered the member BD, which is this part, this member BD. So now we will calculate for the member BD. Oh, sorry. So the applied load on the beam is actually negative 48.09 kilonewton. This is a compression force. So the unit load for BD is negative 2.836, which is also compression. And then we use the equation just now, PL over AE times the unit load. We will get that it is actually 1.25 mm. So lastly, the deflection at C is 4.19, this one, plus this 1.25. We will get the deflection at C is actually 5.44 mm to the downward directions. So this question is quite hard because this question contains another member BD. So we need to use another part of this, which is this part, PL over AE, in order to find the deflection at C. So any question about this question? Any problem?
No.
If no question, then I will proceed to question 6.
Question 6, we have beam, BCD, and then the pin jointed frame there. So we need to determine the value of deflection at D.
Sorry, I think I wrongly clicked something. Oh, okay.
So first we solve for the beam. Okay, here's the beam, and then this is the real beam. We find the vertical reaction for VC and VB, we found that VB is 12 kilonewton downwards. And then we use the same diagram, but we use the unit lot. 1 unit lot at point D. We solve again, and then we find that UB also one unit lot downwards. And then we have here two sections, section B to C, and then section D to C. Here's the formula to calculate it. For section B to C, 0 to 3, we found the real moment and virtual moment. And then we substitute into our equation. And we found that 168.75 over EI for section B to C. We proceed to section D to C. Same method, we find the real moment and virtual moment. And we substitute into the equation. We found that the same with section B to C. And then we substitute the value of EI. And we substitute again into the formula, and we get 3.293 millimeter for B. And then we continue to pin joint frame. First, we need to find the P force. For pin jointed frame, we need to find the P force for each point. So we need to do it one by one. So for joint F, this is joint F. So we get the value here, PEB, PFB, and PEF. We continue again to joint E, value PEC, PEB. Joint C, we get the value for PCB. Joint A, we will get the value of PAB. And then we calculate the U force. Also the same, we calculate joint by joint. Joint F, we can obtain value UFB and UFE. Joint E, we get UEC, UEB. Joint C, UBC, and lastly joint A, UAB. So we use table. It is easier to us for calculate the value for summation of PLU. And then we substitute the value. And then we add the value of the beam and then the pin joint frame. And then we get the deflection at D is 6.640 millimeter.
Okay, thank you for your explanation. This question is even harder from question 5 because it contains of a lot of U forces. So we proceed to the last question, question 7.
Okay, for question 7, we were asked to determine the vertical deflection at F and also at C. So what I did, I divide them into two different parts, which are for Butterworth method for beams and also for trusses. So for the first part, for trusses, for pin jointed frame, as usual, I determine the direction at PE, HE, and also DC. So I get the value. So after that, I determine for real forces, and I get FEF as 100, FET negative 75, FCF 100, FCD negative 125, and FDF 120. That is for real forces. And for the virtual forces, I get FET negative 0.833, FEF 0.667, FEF 0.667 also, FCD negative 0.833, and FDF as 1. So after that, I use the table to calculate the deflection at the end. So by using the equation, I get the value at deflection at F as 5.76 nm. So for the second part, for beam ABC, I determine the fraction. So I get 75 and also 600 for moment at N. So for real moment, that is for the real moment. And for the virtual moment, I get 0.5 and also 4 kilonewton for M for moment at A. So we can divide them into two different sections, which are from section C to B and also section B to A. So calculate the virtual moment and also the real moment. I get 37.5 x squared for section C to B, and for section B to A, I get 37.5 x squared. So we use the integration, for all of them. I get the value as 4.074 mm. So for deflection at F, we add the value for brittle method for beam and also for trusses, and I get them as 9.834 mm downwards. So for vertical deflection at C, since when we apply the unit load at C, all forces at pin jointed frame equal to 0. So we do not need to calculate for that part. So we only need to calculate for the beam part. So as usual, find for the virtual moment and also for real moment, I get them as 75 x squared. And by using the equation to find deflection at C, I get the value as 8.148 mm downwards.
Okay, so any problem with this assignment? I think this is also the last assignment that we have. So if no problems, I would like to say thank you to all of you for your cooperation, and I will stop recording this meeting.